A rotation turns a figure a given number of degrees around a point. Often our problems involve rotating around the origin. Remember where the origin is in the coordinate plane. In this example, we're going to rotate the triangle 90 degrees counterclockwise about the origin. Well, in our table here, this is a shortcut way to tell, if you memorize these, what the coordinate points are going to look like after a rotation. But one important thing to remember is that every 90-degree rotation takes us to the next quadrant if we are rotating about the origin. Often we talk about going clockwise or counterclockwise. If we move this way, that is clockwise. So, like a clock, starting here and moving one quadrant over is 90 degrees clockwise. If I go another 90 degrees, then I'm moving from this quadrant to this quadrant. That's 90 more degrees clockwise. Well, if I put those two together, then I see 90 plus 90, that's 180 degrees of a rotation. So that's how we can figure out 90, 180 degrees, or 270 degrees. Now in this particular problem, we are rotating the triangle 90 degrees counterclockwise. So that means against the way of a clock, opposite of the way of a clock. So from here, going backwards 90 degrees, going counterclockwise 90 degrees is going to this quadrant. This will be counterclockwise 90 degrees. It's often easier to see a rotation if we link our picture to the origin, as if it's like on a popsicle stick, like that. Now I'm going to take this figure and I'm going to rotate it 90 degrees into the next quadrant. Now how do I know when I've gone 90 degrees? Well, you'll notice that if I'm in the next quadrant, now that axis lines up vertically and this axis lines up horizontally. And see how the popsicle stick, I made it stay there, is now at a right angle with where the popsicle stick is before. So there is where my transformed, my rotated triangle will lay, and there is the image. So we're going to put the points of the image in those places. So we're going to take that pre-image and we are going to rotate it 90 degrees counterclockwise. Now how do I know when I've gone 90 degrees? Well, I've made the original figure stay there, and see how my axes are now again horizontal and vertical, and the popsicle sticks, the anchor that was stuck to that triangle, makes a 90 degrees with where it is right there. So my original points that I could label 2, 2, and 1, 2, 3, 4, 5, 5, 1, and 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4, 6. Let's see where they've ended up. Well, we've got this image right here that is at -2, 2, and this one that is at -1, 5, and this one over here that is at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, -6, 4. So do you see what happened to the ordered pairs? They got reversed, and then we can tell what the sign is according to which quadrant it's in. So we know if we go to the left quadrant, then we know we have to go left 6, -6, and then up 4. So we can tell the negative or positive of our coordinates by knowing which quadrant we're supposed to rotate into. Other than that, every time we do a 90 degrees rotation, the X and the Y will change places. Every time there's another 90 degrees rotation, this is two 90 degrees rotations because this is 90 plus 90, the X and Y switched. See how the X and Y switched? Then the X and Y switched again, then the X and Y switched again. So we just have to figure out how many times are we doing a 90 degree rotation. That's how many times we switch, let me spell that correctly, we switch the X and Y on a 90 degree rotation, and then we just have to figure out which quadrant is it supposed to land on. Do you want to try the next one? Rotate this triangle 270 degrees counterclockwise about the origin. So where is that going to land? Counterclockwise 270 degrees. 270 degrees is 90 plus 90 plus 90. It's 390s. Counterclockwise. So that's going to go here, here, and then here. So it's going to end up in this quadrant. This is one 90 degrees, this is a second 90 degrees, and this is a third 90 degrees. So we know it needs to end up in this quadrant. Can you figure out without having to use the visual where the points will end up? Give it a shot. Let's start by labeling these points. This point is at negative 1, 2. This point is at 1, 2, 3, 4, 5, negative 5, 1. And this point is at negative 1, 1, 2, 3, 4, 5, negative 1, 5. I'm going to make my little popsicle stick because I'm going to actually rotate it so that you can visualize it. Can you figure out where those points end up before I rotate it? So this time I'm deciding to take the points with it, just so they're right next to it. Oops, 90 degrees counterclockwise. There's one turn. One more 90 degrees makes 180. One more 90 degrees makes 270. That would have been the same as if I had gone 90 degrees clockwise. So where do our points end up? Our image. Well, let's see if you got these correctly. This is at the point 2, 1. See how the x and y reverse? But now I'm in the positive quadrant. This is at the point 5, 1. Again, the x and y reverse, and now I'm in the positive quadrant. And this is at the point 1, 5. Again, the points reverse, the x and y reverse, and now I'm in the positive quadrant. Did you get it?